Hi everyone, this is Mrs. Snowbeck. Today we are going to review Unit 7 and get ready to take the quiz. For this video, at the beginning of each slide, please pause the video, try the questions, and then unpause the video to see if you get them correct. So at this point, pause the video, try 1 through 5. Okay, so to name a circle, generally what you want to do is use the symbol, so it's circle and then the center letter, which is Y. Now one other way that you might see this written is you might see someone write out the word circle Y, and technically that's okay as well. A radius, remember a radius is going to go halfway across a circle. An example would be segment YT. YT starts at the center and goes to the edge. And so segment YT would be a good example of a radius. Also segment YA and also segment YD. And if you switch the letters around, if you have TY or AY or DY, that's all right as well. Just remember that segments or radii go halfway across, so all three of those would be radii. All right, let's move on to number 3, diameter. Now remember, a diameter is a segment that goes through the center of the circle. So it has to go all the way across the circle and through the center. The only diameter marked in this picture is segment DT. You do not use the center letter in your answer, you only use the 2 endpoints. Next we have chord. So a good example of a chord is down here, RU. Chords have to have both endpoints on the circle. So segment RU is a good chord. Now technically segment DT is also a chord. It's just that this is a special chord because it's the diameter going through the center. But it would be considered a chord as well. And then finally tangent. Remember, a tangent is a line that touches the circle in exactly one spot. So you can take a look up here at the top, right up here. We have a tangent, and we could name that tangent line SN. Now tangents go on forever, they're lines, and so you want to put those double arrows on the end. Go ahead and pause the video again and try numbers 6 and 7. When you're done, unpause the video. Number 6. To find the measure of angle x, or this measure right here, I noticed that it is a central angle. Its vertex is right here at the center of the circle, and so the central angle will be the same size as the intercepted arc. And so x is 124 degrees. To solve for y, now y is not a central angle. Y's vertex is on the circle, and this angle down here is called an inscribed angle. It does open up to the same arc, but to find y, you're going to take 124 and divide by 2. And I think that is 62 degrees for the measure of angle y. Great, go ahead and pause the video and try number 8. The main thing that you have to notice here is one side of the triangle is a diameter, which means this angle right here opens up to half of a circle, which is 180 degrees. This angle then is 180 divided by 2, which means it's 90 degrees. The 3 corners in every triangle add up to 180. So what you're going to do is a little equation like 6x plus 2x plus 10 plus 90, all 3 of the corners of the triangle add up to 180. Now combine your like terms. So we have 8x plus 100 equals 180, and solve it for x. X ends up being 10. And I think that's all we have to do for that one. So the key was noticing that this angle up top was 90 degrees. Otherwise, you wouldn't really be able to do that problem. Go ahead and pause the video and try numbers 9 and 10. So the first question says, find the measure of angle T. As you can see, we have a quadrilateral inscribed in a circle here, And the thing we know about quadrilaterals that are inscribed in a circle is opposite angles are supplementary. So what it means by opposite angles is they're not right next to each other, they're across from each other. In this case, angle M and angle T would be considered opposite angles. Supplementary means they should add up to 180. So to find the measure of angle T, we would do 180, subtract 59, and it would be 121 degrees. Same thing goes for the measure of angle A. So this one's a little confusing because I threw that 3x in there, but really to find the measure of angle A, all you really have to do is look at the angle that's across from it and see that it's 40 and do 180 subtract 40 and get 140 degrees. That is the answer. There is a longer way to do it. The longer way to do it would be like this. 3x plus 40, the two opposite angles, are supplementary, so they add up to 180. You could subtract the 40, and you get 3x equals 140. This is not going to be a nice number. When you divide by 3, you get x equals 46.6 repeating. And then to find the measure of angle A, you would take this and plug it in up here. Well, it turns out 3 times 46.6 repeating is 140 degrees. So either way is just fine. You can do it either way. Go ahead and pause the video. This is our last question that we're going to do as a review together. Try number 11. Number 11, solve for x. Assume that segments that appear to be tangent are tangent. That means that that segment with a length of 4 is a tangent. It comes up to the circle and touches the circle in just one point. So it touches the circle right here. Now that also means that the radii that meets that tangent at the point of tangency is going to be perpendicular. So that is going to be a 90-degree corner. So we have a right triangle. And when you have a right triangle, oftentimes you can do Pythagorean theorem or SOHCAHTOA to find a missing segment or side. The trick here is the one radius that we're given, this one, is x, which means this radius over here also has to be x. All radii in a circle are congruent to each other, and so whatever one radius is, the other radius would be the same. I think we should do Pythagorean theorem here. So what I would do is I would take the two legs and I would go x squared plus 4 squared, and that's going to be equal to the hypotenuse, but the hypotenuse is going to be, as you can see here, it's going to be x plus 2. So I would say x plus 2 squared in that spot. All right, let's try to simplify. X squared, not much we can do with. 4 squared is 16, and this is the tricky part. X plus 2 squared is really x plus 2 times x plus 2, and now you need to FOIL, or box method. So I'm going to go ahead and do FOIL. So that means multiply the first thing in each parenthesis, which is x times x, so x squared. The outsides would be the x and the 2, so I'm going to get 2x if I multiply those. The insides would be here and here. If I multiply those, I get another 2x. And the lasts would be the last thing in each parenthesis. 2 times 2 is 4. So all I did there was FOIL or box method. If you like the box method better, go ahead and do that. That's no problem. Now we're going to combine some like terms. So I have x squared plus 16. And then on this side, I have x squared plus 4x plus 4. Now I notice I have x squareds on both sides of the equation. So next thing I'm going to do is try to get those together. So I'm going to subtract x squared. Whatever I do on one side of my equation, I have to do on the other side of the equation. And in this case, kind of cool, they both cancel out. So we're left with 16 on the left and 4x plus 4 on the right. Keep going, keep solving with your algebra skills. We're going to wind up with 12 equals 4x and x equals 3. The question does say solve for x. I think we have done it. X should be 3. Awesome. So next what you guys are going to do is you're going to do worksheet unit 7 review. And this should help you get ready for the unit 7 quiz. If you have any questions, let me know. Otherwise, have a great day.